Okay, point P, x squared lies on the graph of y equals x squared. So we've got that's x squared, that's the point P. And calculate the minimum distance from the point A to -1/2 to the point P. So the distance is in your formula booklet, and you've got first x minus second x plus first y minus second y. And we're going to put this in the graphing calculator to find the minimum distance. Okay, so here is the graph of the distance. There's the minimum. So the minimum distance is actually the y value. So the answer to A is 1.63. And for B, write down the coordinates of the closest point P to A. So we know the x that has the closest distance is 0.682. And when we square that, we get 0.466. Okay, because remember it has the point x squared. All right, 15, the point AB is on the curve f at x equals x squared, such that B is the point which is closest to A. Okay, so it's the same as last time. We have x squared, and they're saying AB, but really, you know, it's x and x squared. And that could be here. It could be anywhere, okay? And then we've got 6, 0 over here is our point. Now, we need to show that. Okay. So we need the distance equals the square root of x minus 6 squared. So the first x minus the second x squared plus the first y minus the second y, which I'm not even going to put 0 squared. Okay? So this, if we do, so this is all going to be to the 1/2. So we're going to have x to the 4th from this thing. And then we're going to have plus, and then this thing expanded is x squared minus 12x plus 36. So when we do the derivative of the distance with respect to x, we're going to have 4x cubed plus, oh, no, sorry. It could have been fine, but we'll do the derivative of the outside first. So 1/2, all of that, to the -1/2 times the derivative of the inside, which is 4x cubed plus 2x minus 12. Okay, so now this is going to be, I'll factor out a 2 out of this thing. So 2x cubed plus x minus 6 over 1/2, the 2 on the bottom. And then the square root of x to the 4th plus x squared minus 12x plus 36. And that is going to be equal to 0 because we want the closest point. We want the minimum. So when we cross multiply by the square root on the bottom, we just get 2x cubed plus x minus 6 is 0. So that's A. Hence or otherwise, find the value of A. Okay, well, x should be A, but whatever. So we just can do this in the calculator. Hence or otherwise, so you can solve this for x with nsolve or by graphing it and finding the x-intercepts. Or you can graph this and find the minimum like we did in the last one. So I will do this one with x-intercepts. So there's the value of A. It's A is 1.33. And then if we wanted the y, it would be that squared. All right, number 16. A rectangle is drawn so its lower vertices are on the x-axis. Okay. And its upper vertices are on the curve y equals sine x. So there's sine. This is pi, because remember, period is 2 pi. So we've got that. Its upper vertices are like here. Here and here. Something like this. Okay. So let's say let's say this is A, and so if this is A, this point here is A sine A. All right, and it's a rectangle, so it should be symmetric. So this one, okay, let me just draw this out. So this whole distance is pi, right? And then this distance is A, and this distance is A, right? So this distance is A, and this distance is A. So if we want this, if we want this distance, that's just this point here is pi minus A, right? No. Yes. Because we're just subtracting away this A, okay? Now, and then this point is going to be pi minus A sine pi minus A, okay? Which, if you think about it on the unit circle, if this is A and this is A, this angle here is pi minus A, right? Which is going to have the same sign. So really, this point we could also write pi minus A sine A. All right, which is what we're going to do. All right, so that's that. So the area of this rectangle is going to be, so if we want, now in green, if we want this distance, that's pi minus 2A. All right, because we don't want this A and we don't want that A. And the height here is going to be sine A. That is the area of the rectangle. Find the maximum. 4 marks. Jeez. You know, they don't tell us to do it with calculus, but maybe we should practice. So if they don't tell you, which I'm sure they will, you can just put this into the graphing calculator and find the maximum. And you can do that anyways, just to kind of check your answer with the derivative. Okay, so the derivative of A, so I'm going to do product rule. So we have the first times the derivative of the second plus the derivative of the first, which is -2, times the second. And we would set this equal to 0. So this is with graphing calculator. I'll show you both ways on the calculator. Okay, so we will put in both. So bracket pi minus 2a close bracket times sine x. Oh, what am I doing? So this is minus 2x. I didn't even do it right. Okay, so radians. Okay, pi minus 2x times sine x. Enter. Okay, so we know this is from 0 to pi. So if this is 1, 2, 3, 3.14, so, you know, we need this maximum, okay? That's just using the function. That's our answer there so that's A, the angle, and or the x, sorry, the x or the angle, whatever. So that's the answer for the A on the x-axis, and then this is the area. Okay, that gives the maximum area. If we do it with the derivative, so we can do pi minus 2a, oh my gosh, minus 2a x, and then times cosine x plus negative 2 sine x. Enter. So we would need, when the derivative is 0, okay, and this is outside, or yeah, this is going from positive gradient to negative gradient, so this is the maximum, which is going to have, so if you do the 0 of this one, and we want here and here, you get the same x. But then you get that, and you have to sub it back in to find the area, okay? So the area is going to be 1.12. That's the maximum area of the rectangle. You could have also done n solve with this, but just be careful of that, because it needs to be in your domain and stuff. Anyways, whatever. 17. A rectangle is drawn so its lower vertices are on the x-axis and its upper vertices are on the curve y equals e to the negative x squared. All right, so, oops. Okay, so I put this in the graphing calculator. So we get something like that, okay? So we have, it's going to be a rectangle like this. All right, because it's got to be symmetric. All right, so if this is x, this is negative x. So this whole distance for the area is 2x's. All right, and then the height there, this is going to be the point x e to the negative x squared. So that is the height, e to the negative x squared. So the area is going to be 2x length times width, or height rather, e to the negative x squared. All right, so now we can just do this the same as last time. Just find the maximum of that in the graph. Okay, so we get the point at x equals 0.707. The maximum area is going to be 0.858. All right. The other way we can do this is by finding the derivative. So first times the derivative of the second chain rule plus the derivative of the first times the second. Okay, so this is going to be negative 4x squared e to the negative x squared plus 2e to the negative x squared, and factor e to the negative x squared out, 2, that's fine. We're going to have 1 minus 2x squared. Set that equals 0. E is never 0, so we've got 1 equals 2x squared. 1/2 is x squared. So x is plus or minus 1 over root 2. And obviously we take the positive one. And then we would need to substitute that back into our area up here. So we have 2 over root 2 e to the negative 1/2. Okay, so those are the exact values. Okay? All right, 18. A packaging company makes boxes for chocolates. An example of the box is shown. The box has a closed top and bottom, and the box this box is closed, and the top and bottom of the box are identical regular hexagons. Okay, show that the area of each hexagon is that. Okay, so regular hexagons mean all sides are the same. So x, x, and x. And also all angles are the same, which is 60. So the area of one hexagon is 1/2 AB sine 60, which is 1/2 x squared, and sine 60 is √3 over 2. And we have 6 of those. All right? So we're going to have 3√3, so 3√3 over 2x squared, and that is A. For B here, given that the volume of the box, all right, so 90 is going to be equal to, okay, we don't know the height. Okay. So we do know the area of the face. So the area, the volume of this prism, it's a hexagonal prism, is going to be the area of a face, which is the hexagonal face, times the height. All right, that's the volume. Show that when x is that, the total surface area of the box is a minimum. Okay. All right, so that's volume. Surface area is equal to twice the top and bottom, which is 3√3 over 2x squared. And then we have to add 6 rectangles, all of these around, and that's x times h. All right, so we need to solve this thing for h. So 90 times 2 over 3√3 x squared on the bottom. So 60 over √3x squared. So that goes over here. The 2's cancel. 3√3x squared plus 6x times 60 over √3x squared. Okay, simplifying this a bit more, we're going to have 3√3x squared. And this is plus 360x. Nope, no x. The x down on the bottom cancels. So now, surface area. Now we want the minimum. So we're going to do ds with respect to x and set that equal to 0. This is without graphing calculator, by the way. So we have 6√3x minus 360 over √3 x to the 2 on the bottom. Set this equal to 0. So we're going to have 6√3x equals 360 over √3x squared. Cross multiply by the √3x squared. So we're going to have 6√3 is 3. So 18x cubed is 360. Divide by 18. We're going to have 20 cubed root of 20. So given the volume of the box is 90, we solve for h here. We showed that when x is this, the total surface area of the box is a minimum, justifying, of course. So now we need the second derivative of s with respect to x. So we're going to have 6√3 for this one. And then x to the negative 2. So we're going to have plus 720 over √3. And that's going to be x to the 3 on the bottom. All right. And now if we substitute cubed root of 20 in, the cubed root of 20 cubed is just 20. This is clearly greater than 0, which means it's concave up. So at x equals cubed root of 20, surface area is a min.